Welcome back. We're going to be focusing on Module 9, which is measures of spread about the median. The first question asks us, what kind of data set will use the median as its best measure of center? So if you recall back when we were talking about mean versus median as a measure of center, hopefully you remember that the median is good when we have a skewed distribution, because the median is the middle, whereas the average is typically pulled towards the tail of skewness. Range is the maximum minus the minimum, and it's the distance spanned by the data. Now, if I have the numbers 1, 2, 3, 4, 5, and 0, the range is 5. I don't say that the range is from 0 to 5. I actually give a number to represent the range. It's an actual number. For every data set, we can find 3 quartiles that divide our data into 4 subgroups. The way I like to visualize this is if we were to be talking about a dollar bill, we'll make it green for money. We take our dollar and we fold it in half, and then we fold it in half again. We get quarters of our dollars. And so a dollar, we'll consider that to be one whole or 100%. And cutting things up into quarters means that each of the 4 partitions are a quarter. We have the 4th quartile. That means that 100% of the data fall below that. The 3rd quartile, which is 75% of the data. The 2nd quartile, where 50% of the data fall below, and the 1st quartile. These quartiles are talking about this split here because they're talking about the percent of data that falls below that point. So we have 3 splits, but that actually splits into 4 pieces. Each group contains an equal number of individuals. That way, if I have 8 numbers, and I split it in half, and then I split it in half again, there's 2 in each group. Another name for the 2nd quartile, which splits the data in half, is the median. Listing the 5 values that compose the 5-number summary, you start out with the smallest, which is the minimum. It's the lowest number. And then we have the 1st quartile, the median, which is also Q2, the 3rd quartile, or the upper quartile, and the maximum. So Q1 is called the lower quartile, and Q2 is called the median. Q3 is the upper quartile. And then the Q4 would actually be the maximum. What does the IQR tell us? The IQR is the interquartile range. And that's like the range that does the maximum minus the minimum, but with quartiles. So we're taking the 3rd quartile minus the 1st quartile. So it gives you the range of the middle half of the data. Moving on to did I get this, we have a class of 37 students who took a test worth 100 points and were given their 5-number summary. As a reminder, that means that we have the minimum, we have the 1st quartile, we have the 2nd quartile, the 3rd quartile, and the maximum. The middle 50% fell between which 2 values? It's not asking us for the range right now. We're not looking for the interquartile range, but we're asking which 2 numbers it fell between. And remember that that was between Q1 and Q3. So Q1 was 67 and Q3 was 81. So it fell between 67 and 81%. Now we're going to identify whether each of the following statements are true or false. And if it's false, we want to indicate why. All right, at least 9 students scored between 67 and 73. Let's think about this right now. We have the lowest number is 55, and then our 1st quartile is 67, and 73 for our median, 81 for our upper quartile, and 98 for our maximum. This means that we have 25% below this value, 50% below this value, 75% below this value, and 100% of the values. 100% of the values fall below 98. And since there's 37 students, if we cut that in 4, you're roughly going to get about 9 with 1 left over. So there should be 9 in each of these values since we're talking about splitting things equally. So at least 9 scored between 67 and 73. That's true because we do have at least 9 there. It could be that there's the one more, but typically that's going to be the median. So we would say, yes, this is true. At least 18 students scored below 67. Well, 67 is quartile 1, and we're saying here that there would be 18 students. Well, that's about half, so that's false. If we wanted to correct that when we're talking about half, we would say at least 18 students scored below the median, which is 73. At least 25% of the students scored an 81 or above. So 81 or above is right here, and they're saying 25% goes from 81 or above. That's true. And at least 25% of the students scored a 67 or below. So again, 25% falls in the last quartile. Yes, that's true as well. Okay, and we're asked to revisit the StatCrunch data. So I'm going to open StatCrunch and we're going to work through there. In our StatCrunch data, we need to load the data that we're talking about. So we're going to go to Data, and we're going to load it from a shared data set. Now, remember, we're looking for the serial data that is owned by StatCrunch Featured, which is right here. They were asking us to compute the 5-number summary as well as the interquartile range for the sodium column. So I want to go to Stat, and I want to calculate some summary statistics based on column data. And the column that I'm concerned with is sodium. And then I can go ahead and click Compute. We're talking about sodium here, and we're asked to list the 5-number summary. Remember that the 5-number summary is the minimum, the maximum, the first quartile, the third quartile, and the median. And we typically like to put them in order. That gives us 0, 130, 180, 210, and 320. Now, question B says, the sodium amounts vary by how much? They're asking what is the range here? And the data ranges from a maximum of 320 to a minimum of 0. So 320 minus 0 is equal to 320. That's how much the data vary by. The middle half of sodium amounts vary by how much? Well, now they're asking us for the middle half range, which is the IQR. That's Q3 minus Q1. So 210 minus 130 is equal to 80. What percentage of cereals have a sodium amount less than 130? 130 is at our Q1. Below our Q1 is 25%. And then for part E, it says what percent have a sodium amount less than 210? 210 is our third quartile, which means that 75% of the data fall below 210. Now we're going to use the interquartile range to identify potential outliers. In order to find outliers, you use a certain formula that involves the interquartile range. Outliers are calculated by taking 1.5 times the interquartile range and adding that to the upper quartile or subtracting that from the lower quartile. Here's what that looks like. First of all, we have to find the interquartile range. And we already know that the interquartile range is 80. Now we're going to take 1.5 that. So 1.5 of 80 is equal to 120. Then we're going to add that to the upper quartile and subtract it from the lower quartile. The upper quartile is 210 plus 120 equals 330. The lower quartile is 130 minus 120 is equal to 10. Let me give you a visual of what that looks like. Let's say I have this number line, and I have my minimum, my first quartile, my middle, median, my upper quartile, and my maximum. The interquartile range is here, and what we're doing is we're taking 1.5 of that below your lower quartile and 1.5 of that above your upper quartile. So let's say I had a data set that looked something like this. Where my minimum was way down here, my upper quartile, my lower quartile, my median, my upper quartile, and my maximum. My interquartile range is pretty small here. So 1.5 that is going to look like about this. So anything below this value would be an outlier. And anything above that would be an outlier. So it's creating fences to determine whether something's an outlier or not. And I often get asked the question, what happens if it's exactly 1.5 times the interquartile range? We never really experienced that, and I don't have a hard and fast answer in terms of that's an outlier or it isn't. So I think that's just kind of a generalized, I'm not really sure. We have what's called extreme outliers as well, which uses 3 times the IQR. Box plots are a visual representation of data that can summarize our distribution, and it uses the 5-number summary. It used to call it a box and whisker plot, but it's just kind of abbreviated as a box plot. And you can create them in StatCrunch, so pretty easy to do. And they're actually pretty easy to calculate by hand. So we use these 5 data points, plot them on the graph, we make a box around the middle 50%, and then we create lines out to the minimum and the maximum. So the box is Q1 to Q3, and then there's a line down the middle. The whiskers, if you will, or the lines that go from Q1 to the minimum, and they go from Q3 to the maximum. And any outliers are 1.5, the interquartile range plus Q3, and Q1 minus 1.5, the IQR. Using the numbers that we had, the minimum is 0. The first quartile is 130. The median is 180. The third quartile is 210. And the maximum is 320. We make a box around the middle half, draw a line through at the median, and then we connect the Q1 and the Q3 to the minimum and the maximum. Now, box and whisker or box plots can kind of give you a picture of skewness, but notice you're only using 5 numbers. You don't really have a picture of what the data is, like a dot plot. Let's say I had a graph that looked like this. This long tail here shows skewness. If you have a box with equal tails, this is symmetric. You want to be careful of if the tail is longer on one side, you've got some skewness going on. So we're going to go back to StatPlot now, or we're going to go back to StatCrunch now.